Week 14, lesson 2. Okay, so this is more practice with complex numbers. And there's going to be a little bit of some new notation. Okay, so you can read this here for yourself, but more than anything, you just need to know that if you're given a complex number, right, which has a real part and an imaginary part, and then you see this notation, like a little asterisk next to it, all that's saying is that you have the complex conjugate. All that means, literally, don't make this complicated. It's just that the imaginary part becomes its opposite. Literally, that's it. Okay, so if you are given this problem, okay, so again, here are two complex numbers, right? Here's the first one underlined in red. Here's the second one underlined in purple. This is saying, let's take the first one, right? Let's take the first complex number, and let's add it to the complex conjugate, sorry, that should be in purple, of the purple one. So the complex conjugate would be 4 minus I. All right, so now, literally, I can't make this any easier. Let's put the real parts together and get 5. Let's put the imaginary parts together and get negative 4I, and that's the answer to this problem. Okay, next example. Same original complex numbers. So this one is saying we're going to divide. We're going to take the first complex number, the 1 minus 3i, and we're going to put it over the other one, which is 4 plus I. Now the problem here is that you're not allowed to have a radical in the denominator, and that's what I is. So the way to rationalize this is to multiply the top and the bottom by the complex conjugate of the denominator. Okay, so if you FOIL this denominator, you will get 16 minus I squared, or in other words, 16 plus 1, which is 17. Now for the top may take a little bit more work. I'm going to have to FOIL this. So the first term's 4, the outer and the inner, when I do that, become negative 13i, and the last is 3i squared, or in other words, negative 3. So negative 3 and 4 make 1, and this negative 13i comes down. That is the answer to this problem. Okay, for this next example, you're given this complex number and you are asked to raise it to the third. In other words, 2 plus I to the third. Now, you could do this as 2 plus I times 2 plus I times 2 plus I, right? There's no shame in that. But I did teach you how to do this with binomial expansion, which is how I'm going to do this problem. You may have to expand out Pascal's triangle, if you remember, but each of these blanks needs to have 3 things. It needs to have a coefficient, which will be 1, 3, 3, 1. It needs to have something dealing with this 2. This will be 2 to the third, 2 to the second, 2 to the first, 2 to the 0. And it has to have something dealing with this I. So down here, I have I to the third, and I to the second, and I to the first, and I to the 0. And then, lastly, every blank needs to be simplified. Okay, I'm going to leave a lot of that to you. This becomes 8, this becomes 12i, this becomes negative 6, and this becomes negative I. And then when I simplify, right, and put the real ones together and the imaginary ones together, I get 2 plus 11i. All right, so this is the last example. Again, same exact complex number, but this is saying that you're going to take the complex conjugate, so 2 minus I, and raise it to the 5th. All right, and I'm going to do this the same way that I did the last one. I'm going to do it with binomial expansion. So that means that I need 6 blanks. 1, 2, 3, 4, 5, 6. You may have to expand out Pascal's triangle somewhere. I'm not going to do that for you, but if you ask me in Zoom or in person, I definitely will. So let's put the coefficients in first. So 1, 5, 10, 10, 5, 1. Next, and I will switch colors for you. I'm going to put something dealing with 2 in each one. This is 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0. And then lastly, and you got to really watch the signs on this one, we have to put negative I in each of these blanks. So negative I to the 5th, negative I to the 4th, negative I to the 3rd, negative I squared, negative I to the 1st, and negative I to the 0. Okay, now I am going to let you simplify each of those blanks, and I am not writing it in the notes. I will write the final answer, right? So I'm expecting you to come up with what each of these 6 blanks simplifies to be, and then when you combine your like terms, you should get negative 38 minus 41i.